Hello everyone, and thank you for joining another DIY Engineers video. In this video, I'll be going over the 1602 LCD. In case you didn't know, LCD stands for Liquid Crystal Display, as you can see here, and the 1602 stands for the 16 is 16 characters per row or line, and the 02 is basically 2 rows of text or 2 lines of text. Now here you can see all the pins associated or connections associated with this LCD. We start with ground, which connects to the ground of the Arduino, the VDD, which basically takes the 5 volts from an Arduino or other microcontroller. V0, it's used for LED contrast, also the text against the backlight, and we'll see that contrast in more detail later. Then we have the RS, which is used to select that's the register for selections of the command or data transfer. Then we have RW, which is just are you reading or writing. E, which is used to enable or disable the LCD. Then you have the data pins, D0 through D7. And then we have A and K, which is for backlight control. Now, there are a couple of ways of how to connect this LCD to an Arduino. In this case, we'll show an Arduino UNO. And you can see the conventional method or standard, and then the I2C. So in the conventional, you can clearly see that all or a large portion of the digital input outputs of the Arduino are taken by the cables that we mentioned earlier, or the pins, which are the data pins. And here we're sending data pins D7, 6, 5, and 4 from the LCD, which is taken 4 through 7 on the Arduino. And then we have a few others for enable, as you can see on pink, and then the RS go into 9 and 10. So you can see that it's taken a lot of the digital input outputs, whereas the I2C method, I mean, other than the 5 volts and ground, which is also the same in the conventional method, all you got is 2 cables going to the Arduino on the I2C ports, S, DA, and SCL. So, different methods, different requirements, and obviously different number of pins taken on the I/O. So there are some advantages on the I2C. Now let's cover the connections on the conventional method first. As we talked, the first pin goes to ground. So in this case, we have a breadboard. We show the ground pin going from the ground of the LCD to the ground rail on the breadboard, which then is taken and connected to the ground on the Arduino. VDD is connected to the positive rail on the breadboard, which is then connected to 5 volts on the Arduino UNO. V0 is to the middle leg of this potentiometer, which is used for contrast control. See, for example, how the contrast on the LCD shown on the screen changes as I turn the knob on the potentiometer. Then RS, which we said it was for register select, will go to digital input output number 9. Then we go to RW, which will go to ground. Then we have E, which is going to digital I/O number 10. And then we have the data pins, which will go to digital input output 4 through 7 on the Arduino UNO. And then we have the backlight controls, which in this case we're just sending to 5 volts and ground on the breadboard, which again we said we're connected to 5 volts and ground on the Arduino UNO. Now let's talk about the I2C method. A little simpler, as we said, less cables other than the ones going from the LCD to the module, the I2C module. We have ground going to ground on the Arduino. Then we have the VCC on the I2C module going to the 5 volts on the Arduino. Then we have SDA with SDA and SCL with SCL. So pretty simple. And if you're wondering, contrast control on the I2C method is handling by using a small screwdriver to change the setting on the built-in trim pot to essentially it's the same thing as adjusting a potentiometer to change the contrast. So now, when we talk about the required libraries, the conventional method uses the Liquid Crystal library, which is a built-in Arduino library. included in Arduino IDE by default, so you don't have to download anything. Whereas the I2C method uses the liquid crystal underscore I2C, which you would need to download from GitHub. Okay, if you check the description for this video, you will see that I provided a link to this GitHub library. All you gotta do is click on it. You will see this page open up. Go ahead and click the drop down here on the green button, and then click on download zip. Alright, so once you downloaded the zip library, all you gotta do is go to Sketch, Include Library, hover over to Add Zip Library, and click there. Once you get to the location which you placed the library after downloading, go ahead and select it and click Open. I won't do that because I have already installed mine, but you go ahead and click Open. I'll click Cancel. Okay. Alright, now the easiest way to copy and paste the code that I'm about to explain in this video will be to go to DIYengineers.com, specifically the link shown in the description, and copy and paste this code that I'm hovering over right now. I have both the code for the conventional method that I'm about to explain, as well as the I2C method. So, go ahead, head over there, and copy and paste it. So now I'll go briefly over the code. Here, well, I guess the first line first, we include the library, the liquid crystal library. Then we specify the pins that we're going to be working with. So 9 and 10 we talked before. We showed it actually on the breadboard diagram. And we showed they connect to R, S, and E for enable. And then we have 4 through 7 on the Arduino I/O, which connect to the digital pins, or data pins, sorry, on the LCD. So then we begin on the void setup, the LCD, where we specify that it's a 16 column or 16 character LCD with 2 rows. Then on the loop, we simply set the cursor to the beginning of the first row. We print the message that we want to print on the LCD. Then we move to the next row. We print another message. We delay. We clear, and we could repeat this. You could literally use this for any other example or project, but this is what we're showing at least for this first example. Now if we head over to the I2C code, there are mainly 2 differences. One, we're going to be calling the liquid crystal I2C library instead of the regular liquid crystal, because of course this will be based on the library we just downloaded. And you also have you have to call liquid crystal I2C instead of the other one. And we specify the number of columns or characters and the number of rows, but we also specify here the address, which I have as 0x27. Now, you might run into issues if the predefined address of your I2C module in the for the adapter, right, for the LCD is not set up for this address. It might have a different address. I have a link in the blog post that you just went to copy the code under possible issues that calls out. Let me just show it. Here it is. So here right below where you copy the code, you see here possible issue, and I call that on line 4. We call out this address, which is the same one I have in the code I was just showing you. And the one way to get around it is to run a code that will help you determine the address, and that code can be found on this link. I also went ahead and included it here. So if you click here, it'll include the full code. You can run this, and you will then open the serial monitor. Well, you will see what the address for your device is. You only need to do this if you're having issues running the code that I was just showing. So other than that, there's no other differences between the 2 methods from a programming standpoint. Let's now go ahead and take a look at the results. We can see in the first row we get DIYengineers.com printed, and then the second one 1602 LCD. If we get close up, we can see the quality and how the image looks. We can see the contrast is set up properly after we play with the potentiometer for a little bit. Now let's go ahead and unplug this and let's rewire it for the I2C method. plug everything. Show you real quick the module, place it next to it, and then all we gotta do is connect the 4 wires. Plug it back up, and there you go. DIYengineers.com again. And that's it. So I hope you enjoyed this video. Thank you very much for watching it. If you did like it, please give us a thumbs up and subscribe. Thank you very much. Bye.